So hi everyone, in this one we are going to talk about quorum consensus. So the quorum consensus says that write quorum plus read quorum should be greater than n, where n is the number of nodes of the database, or I can say the number of replicas, and R is the number of votes required before a read operation can be marked complete, and W is the number of votes required in order to mark a write operation as complete. So, what does this mean, and why do we actually need quorum consensus, and how does it help us? So, so let me start with what happens in a typical distributed system. There's this theorem that we have all heard of, which is the cap theorem, which says that in a distributed system, we can either compromise on consistency or either compromise on availability. We cannot compromise on network partitions. P stands for network partitions. And so we have to choose one of it. So either we can choose consistency and network partition tolerance, or we can choose availability and network partition tolerance. So if I try to increase my consistency, there can be an impact on availability. And if I try to increase availability, there will be a reduced consistency. So why does this happen? Let's see how does this happen. So let's start with increasing consistency. So as we all know that consistency means that all of the nodes in my distributed system have the same copy of data so that any read operation, let's say there's a client, here's we have a client and client does a read operation. So now this read operation can be going to any of the replica, we don't know which one, and we expect this to return the most recent version of the data because we are focusing on strong consistency. So all of the replicas should be having the latest version of the data. Then only we can achieve strong consistency, right? So in order to achieve strong consistency, what needs to happen is, let's say, whenever a write operation comes in, what will happen is the write operation goes to this master node, and then this master node will write the data to itself, and then it will propagate the data to its replicas, to all of the replicas, right? Now this master will wait for an acknowledgement from all of the replicas, and then only it will mark the write operation as complete. So the problem is when the write operation is propagating to all of the replicas, what can happen is, let's say any one of the replica crashes. So since it crashes, this won't be able to write the operation to itself and cannot send an acknowledgement back to our main master node. So in this case, since we do not receive an acknowledgement from all of the nodes, the master node will say the write operation was incomplete and could not be processed successfully. So when the write operation cannot happen, this means the system is not available because the client tried to write something but cannot write. Hence, the system is not available. So the problem is that even that only one node crashed here, our system became unavailable. This is because we wanted strong consistency, which meant that all whatever data that is returned on all of the nodes, and then we send an acknowledgement to the client that okay, now your data is returned to the database. So one thing we should know in distributed systems is that we cannot avoid network partitions or a node crashing because of hardware failures or due to temporary glitches. There is always a possibility that any node in the distributed system can face temporary problems. So it is always going to be there. So we needed something which could balance consistency and availability despite being in the face of failures. So that's where the quorum consensus kicks in, and it provides a balance between consistency and availability. I'll explain how in a minute. And it helps us to provide a system which continues to operate despite the node failures. Okay, so now let's see what does W plus R greater than N actually means. So quorum basically means voting. So let's see in action how does it work. So now let's say we have a client which tries to perform a write operation. So according to quorum consensus, W plus R should be greater than N. I want to add a little more detail to this is usually by standard what we want to do is we want to select W as n plus 1 by 2 and R as n plus 1 by 2 as well, where n will be odd. So let's say in this case we have n as 7 because our number of nodes are 7. So 7 plus 1 by 2 will get us 4. So this means that there should be at least 4 nodes that need to acknowledge to a write operation in order to mark it complete. So whenever a write operation comes in, this node will write the data to itself and then propagate it to the replicas. And then this node will wait for at least 4 acknowledgements before completing the write operation. So here you can see that our number of nodes are 7. Earlier, when we wanted strong consistency, we were waiting for write acknowledgement from 7 nodes. But now this is not the case. We are only waiting for the acknowledgement from 4 nodes. So we have brought it down by 3 nodes. This means that even in my system, if 3 nodes fail, let's say this node, and this node has failed, even then I will have 4 nodes which are in working condition. And if I get 4 acknowledgements for my write operation, I'll mark my write operation as complete, as successful. So in this case, the system is available despite node failures. So quorum consensus helps us achieve availability. Now let's see how does it helps us achieve consistency. So now let's say there's a read operation that comes in by the client, and at this point of time, the nodes that were crashed have recovered themselves, right? These nodes have recovered themselves. So in case of read operation, what I'll do is I will query at least 4 nodes, and after only after I query 4 nodes, at least 4 nodes, then only I will return the result to the user. So let's say I pick up any 4 nodes at random. So let's say I pick up this node, I pick up this node, I pick up this node. Now these nodes had an older version of the data because these nodes were crashed and we could not write the most recent data to these nodes. So let's say these nodes contain the data which was of version 1. This was containing version 1 of the data. This was also containing version 1 of the data. But the nodes in which write operation was successful were containing version 2 of the data. So now, since we have selected 3 nodes for read operation by now, let's say we have selected these 3, I have to select one more node. So I have to select it from, if you can see, I would either select one more node from here, 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 or here. I have these 4 options, right? So if I pick up any of the node, doesn't matter. Let's say I pick up this node. So this node contains version 2 of the data. Now I'll say, okay, the read operation gives me 2 versions of the data. It gives me version 1 and version 2 of the data. And with time stamping, I would know that version 2 is the newer version of the data. So since version 2 is the newer version of the data, the read operation will return this to the client. And hence, we also achieve consistency. So the quorum consensus will always make sure there is at least one node which overlaps between the read quorum and the write quorum, and hence it provides us with availability and also with consistency. Now we can also adjust the value of write and read quorums according to what type of systems we have. So if we have a system where there are a lot of write operation, what I can do is I can reduce the value of the write quorum and increase the value of the read quorum in write heavy systems. Why? Because I need to write faster. This means what I'll do is I'll want to have less number of acknowledgements for the write operation so that my write operation can be marked complete as soon as possible. Similarly, if the system is read heavy, what I should do is reduce the read quorum and increase the write quorum. So this makes sure that our read operation are marked complete very quickly, and since there are lesser number of writes, I can take a little bit longer time to do the write operations. So just know that node failures are inevitable. There will always be some node failures going on due to network partitions, some temporary glitches, or hardware failures. And hence, in that situation, we would still want our system to be available and consistent. And that's where quorum consensus helps us to achieve that. And that's it for this one, and I'll see you in the next one.